I purchased this vintage Apple computer for just $30. It's quite an early one, released in 1991, known as the Macintosh LC. According to the seller, the power supply blew up when he tried to test it. Unable to wipe it, he removed the hard drive. He originally purchased it for his wife, new in 1991. He had a few other vintage Macs from his graphic design business also for sale, but he wanted quite a lot more for them. Because this one didn't work, he was willing to let it go for very cheap. It's quite grubby, and while I don't know where it's been stored for the last few decades, some of this grime, like that's on the keyboard, has been accumulated whilst it was still being used. When I went to collect it, the seller showed me the hard drive he'd removed, and lucky he did because it still had the bracket and cables attached. If you're buying a computer where someone's removed the hard drive, make sure to get the bracket and cables that go with it. But not only did I get the computer, but also all of its original documentation and installation floppy disks, which we'll need later. But finding the original retro Apple stickers too, well, they're worth more by themselves than I paid for the entire computer. So we're off to a great start. Apple computers from the 80s and 90s are not like those today, in that they expected you to open the case and upgrade and replace parts. It couldn't be any easier to open this LC. Inside, everything is accessible and removable without any additional tools, as if this is a Dell Optiplex or some enterprise machine. Concerningly, it still contains its original clock battery, which thankfully hasn't leaked. Equally of concern is the surface mount capacitors on the motherboard, which look to have just started to leak. Capacitors and clock batteries are the biggest killers of vintage electronics, as a substance that leaks from them can cause major corrosion which damages circuit board traces. That's what I'm hoping has caused the power supply to fail, so I've ordered a replacement kit for both the power supply and motherboard. Picking up a kit is fairly inexpensive and saves you the hassle of trying to find each value and voltage rating of every capacitor. To remove the power supply, the one connector needs to be unplugged before it's unlatched and lifted out of the machine. Without even opening it, we can see capacitors have leaked, oozed out their substance onto the casing of the computer. 3 Phillips screws hold the power supply together. Opening it does pose a risk, so if you attempt something like this, make sure you undertake the proper research on electrical safety, as these do hold mains charge even when unplugged. Nothing inside looks as though it's exploded, although the glue on the transformer has lots of bubbles, so maybe it's gotten hot. In this Aztec power supply, there are 6 reefer capacitors, known for their exploding capabilities, along with lots of leakage around the low voltage section. I'll get the board removed and do some preliminary checks. The fuse is blown, so that means something certainly went wrong. So that's the first thing I'm going to replace. Next is all the electrolytic capacitors, especially those on the low voltage side, and the reefer capacitors, all of which were included in the kit I purchased. You don't need to see signs of bulging to have bad or leaking capacitors, which is a common misconception. Just have a look at the mess these ones have made. Thankfully though, no major corrosion has been caused. I'll clean up the area before the new ones go in. I didn't want to power this supply on without first replacing its capacitors. However, with a blown fuse, it wouldn't have done anything anyway. Once I've completed the recap, it was time for a test. Installing the unit in the LC, I could connect a power cable, and it tripped my circuit breaker straight away. I would go on for hours troubleshooting, finding and replacing a blown resistor to no avail. I gave the supply off to an ex-electrical engineer from my local repair cafe, who believes it to have a bad transformer which is causing all the issues. That's not really something fixable, so a new power supply it was. Specifically, a TDK version. This one came from John of Roadkill Incorporated. It's a known working unit, although without having a recap, I only brought it up on a variable power transformer to about 100 volts for testing. The monitor, however, it was described as still receiving power. I suppose that's not technically wrong, but something about it is. So it looks like before I go any further, I need to open up the monitor and see what's going on. Don't open or try to repair a CRT without first understanding the dangers and how to mitigate them. The flyback transformer inside here generates many kilovolts. They're called kilovolts for a reason. 2 screws and 2 clips need to be unlatched before the back casing of the Apple RGB monitor can be removed. Immediately after, we need to discharge any potential kilovoltage that's being held in the CRT tube. A lead needs to be connected from the DAG ground to a screwdriver, where it can be used to short the flyback lead that's connected to DAG ground. Just be sure to use a screwdriver with a plastic handle and not one with a metal top for obvious reasons. Many sets have a built-in resistor to discharge the CRT once power is removed. However, you can't always rely on the set having a working one, so this must be done every time. I got no spark, so it's already discharged, or the high voltage wasn't generated as part of the fault. Currently, this monitor sounds like an old hard drive spindle. When I typed that into a search engine, I didn't really get any decent results, other than it may be failing to start and entering some kind of safe mode. I wasn't able to remove the main board without first disconnecting the neck board. This needs to be done very delicately. After rotating the white locking mechanism, it can be lifted off. The neck is made from thin glass, like that of a typical valve in a radio, so if it breaks, the tube is unfixable. With the board out, I could straight away see an issue. As if we couldn't have guessed by now, leaking capacitors. While looking up general faults with this specific model of monitor, this capacitor was a known failure point, one that seemed to affect all units. A bad capacitor here will cause geometry issues with the CRT, but nowhere did I find if it would cause the monitor to buzz and not switch on. It had caused some minor damage, far less than examples I found online. Another sign of leaking capacitors is the sizzling you get whilst desoldering. I continued by pulling out the other large capacitors, another Rubicon, a 35V 2200 microfarad, also leaking. However, the one next to it, a Nichicon, perfect, it even tests good. This was the only one I couldn't find a replacement in time for the video, but he's looking alright for the moment, so he's going to go back in. There was another Rubicon, again it had started leaking. After 35 years, it's expected. But it also shows you why hoarding vintage gear isn't a good idea if you don't replace parts that are prone to leaking, because you're actually just slowly destroying it. An effective way to remove flux and capacitor gunk is using IPA and a paper towel, brushing on top, which causes the grime to collect in the paper and not just be smeared around. The back cleaned up quite well also. Checking it with a multimeter, the tracks are intact and functional. So it's time to get the new capacitors installed. They're only from my local electronics store, so they might not be the best choice, but they're all I could get at the time. But hey, even a Rubicon leaks. There's still a couple in here that I'd like to replace in the future when I source some more capacitors. However, I will have replaced most of the major ones. Once I get them soldered in, I can snip off the excess leads. After looking over the whole board, I couldn't find any other obvious issues, so I'll give it a dust out and get the monitor back together for a test. Sliding the back cover on to prevent me from touching any high voltage, I'll get it plugged into my isolation transformer and bring it up slowly on my variable transformer. And you can hear the high voltage kicking in. With the LC hooked up, we've got an image. With the monitor working, I want to get the replacement power supply recapped. Everything so far has had leaking capacitors, and I bet this power supply is no different. It comes apart a bit different to the Aztec, better in fact, as you can work on it without the need to unsolder the AC plug. I'll short out the main high voltage capacitor to again ensure no high voltage remains before beginning the recap. This one's leaked quite significantly. It's wet, yet it still works. Pulling all the old capacitors, some have leaked more than others. 2 ulnar caps were particularly bad. Just have a look at the board. You can see just how far it's spread on the back. I only hope that once it's cleaned, the corrosion doesn't continue to spread, even after replacement of the capacitors. I'll fit all the new capacitors, some of which came from the first kit I ordered for the other power supply. Then, with everything soldered in, the power supply can be put back together. And it's working perfectly. I also tested the floppy drive at this point, and it's booting the original installation floppy. But if you think we're done, you're wrong. We've got to get the logic board out and service it too. Just 2 tabs and it slides out. This computer is powered by a 68020 32-bit CPU and has been maxed out with 2 4MB RAM modules, bringing the total RAM to 10 MB, which includes the inbuilt memory. Running with the theme of bad capacitors, the ones on the motherboard need to be replaced. I'm going to replace these before they cause any serious damage. Unlike the previous through-hole capacitors we installed earlier, these ones are surface mounted. I purchased a kit to replace all 15 electrolytics with tantalum capacitors. That way we won't have any leaking issues in future. Removal of the old surface mount capacitors is daunting, as we need to remove them without damaging the tiny solder pads on the PCB. 2 common methods include twisting the capacitor back and forth with a slight downward pressure, or cutting the capacitor clean off. I'm going to try both. While it's a bit painful to watch, apparently it's the way to go. The twisting action breaks the legs off at the capacitor, leaving the plastic base to be removed and the remnants of the legs desoldered. I'll use the same cleaning method as before to ensure no capacitor leakage remains. Once a capacitor is removed, it can be replaced with a tantalum. Unlike electrolytic variants, the line on the tantalum capacitor indicates positive, so this line needs to be orientated to the plus on the PCB. Then I can tack it in with a soldering iron. I've never recapped surface mount capacitors before, so this is a new learning experience for me. Because these capacitors sit on top of their solder pads, they're harder to desolder in the usual method. Though hot tweezers would probably be the best way, however I don't own any. As I was installing them, my soldering improved. If you're going to try something like this yourself, ensure the pads are flat and have little to no solder on them. That way the capacitor sits flat, so when you add solder it connects to both sides easily. Where I left some solder in place, heating one side would cause the capacitor to sink into the old solder, making the adjacent side difficult to attach. Twisting the capacitors off worked well for the larger ones, where I felt my side cutters were too small and likely to cause fatigue to the pads. For the smaller capacitors, cutting them off worked well, although you need to be careful when removing the remnants of the base not to pull upwards or jar the piece, as you could still rip a pad from the board. The remainder of the legs need to be trimmed to allow the plastic base to lift off, leaving the pads ready for cleanup as per the previous method. Where the twist method is particularly dangerous is when attempting it around other components. I knocked one of the capacitors I had already installed. Thankfully though, nothing was permanently damaged. I removed the large section of capacitors in one go to allow for easy cleaning, with the location of each capacitor found in the guide included with the kit. testing the fitment of each new capacitor to make sure nothing's loose. Then it's just the case of removing any residual flux. With all 15 installed, it's time to get this Macintosh LC reassembled and an operating system installed, that is, after a quick dust out. Switching it on, nothing. Looks like I just forgot to attach the fan and speaker. No wonder it was so quiet. That's better, but we're no longer getting a blinking question mark, and it's not booting from the floppy. This thing is going to fight me all the way. I checked everything, only finding a piece of an old cap resting on pins of the CPU, which wouldn't be helping. But there's still no blinking question mark. Because I lacked the original hard drive, I purchased this, a blue SCSI drive emulator. Using an SD card, we can load up images or just use it as a hard drive replacement. It required its own assembly and a custom cable, but once installed, the blinking question mark returned. I believe not being able to find a drive at all was causing the SCSI bus to hang. So it's in with the install floppy for Macintosh System 7.0.1.
Oi, I want to install that.
I ended up imaging System 7 to the blue SCSI, which got the machine booting. Now I can print a bracket to secure the blue SCSI to the original hard drive bracket, securing it with its original screws. Connecting the SCSI and power cables to the drive, it can then be clipped into place. The lid can be put back on with its one screw, and the Macintosh is ready for a much needed clean. After the dust is blown away, some soap and water can be used to clean off the rest of the grime. There was also a piece of tape over the floppy drive, which is odd. Maybe they had a young child that was putting things in there. The monitor and keyboard were by far the most dirty, with the mouse also needing its rollers cleaned from dust, as I had noticed some tracking issues when I initially tested it. Now it's finally time for the keyboard. Grime from decades ago has been left to ferment. Let's hope it comes off. Here's before and after. It came up great. And we're done. So this is it, a Macintosh LC. It's taken me 6 months and over 10 hours to finally get it working. From a fried power supply, a faulty monitor, and many leaking capacitors, it fought me all the way. In the end though, it didn't cost much, just mainly the time involved. This is a color monitor, so switching it to 256-bit color, things are looking a bit better. The system image I have here is from a PowerBook, so there's some PowerBook specific apps which don't work. I will get the correct install on here, but for today this will have to do. I've never really used a computer this old. I was born in the early 2000s, so I grew up with Windows 98 and dial-up. If you have any software suggestions, let me know, because I don't know what to do with it now that it works. I adjusted the height of the picture on the CRT, but there doesn't appear to be one for the width, so maybe it's inside the monitor. But it's working for the first time in decades. If you've got a computer or vintage electrical gear that's 25 years or older, you really need to check the capacitors right away. This computer is a great example of why. You're actually slowly destroying it if you don't take care of the capacitors. I think we saved this one just in time. And on that note, this has been a Hugh Jeffries video. If you like what you saw, consider subscribing and check out the computer playlist for more videos just like this one. And if you're looking for any used devices, be sure to check out my online store, link for which is down in the description. That's all for this video, and I'll catch you guys next time.